Okay, thanks everyone for sticking around toward the end. I appreciate it. And I'll try to make this fairly quick and just refer you to some resources. This is summarizing key findings from a CERDIP project.
Elizabeth, we're not seeing your screen.
Oh, let me try again here. Okay, I've got the share up now. Let's try presentation mode.
There you go. We got it.
Okay,
That's great. Thanks.
So my co-authors are listed here on this slide. Again, the project is to assess and mitigate bias during PFAS sampling, and we're focused on groundwater and surface water sampling. And this is a multi-collaborative team. Many different organizations. Our principal investigator and the project lead was Dr. Jennifer Field from Oregon State University. So I'll just briefly cover our project objectives and motivation, talk about the results to date, which are summarized in this report, which is publicly available and posted on CERDIP's website, and then talk a little bit about emerging research into PFAS surface water sampling. So when we're talking about bias in PFAS concentrations during sampling, that includes positive bias, given that PFAS are present in a wide variety of different materials and field equipment. I'm showing a few examples on this slide. You can also have negative bias, losses due to degradation of some PFAS to form others, or sorption to your sampling equipment. And then we also looked into partitioning because PFAS can behave like surfactants and preferentially accumulate at interfaces like the air-water interface. We wanted to research how much of a difference that would make in a sample result and whether the sampling procedures would need to be modified on account of that. So the first task of the project was really focused on the field equipment and materials and their potential to contribute PFAS to samples. And we were really interested in whether current sampling guidance, or to what extent the current guidance out there is based on science versus an abundance of precaution. And noted that, a lot of the restrictions on sampling protocols that are being issued by states and others, federal agencies, do add time and cost to field efforts. We also wanted to look at the effect of sample storage on PFAS concentrations, including the storage temperature and hold times. And then we did some original research to assess the partitioning at the air-water interface. So the publication that summarizes a lot of the early work on field materials and equipment was published by Rodoa et al. In 2020. This is work that was done in Dr. Field's laboratory. And the team gathered up materials that are commonly used in the field during sampling or in advance of sampling, including personal care products that might be used the morning of or the night before. And then to be conservative, rather than soaking them in water, soak them in methanol to increase extraction. And then analyze the extract for 50+ target compounds and total organic fluorine. And so in our technical guidance document, we've compiled results from these experiments and then previous publications and provide those in summary tables as a centralized resource of what materials have been shown to not contribute PFAS and materials that could contribute PFAS. And we also went through and compared the language that's used in various guidance documents and identified a few areas where guidance differs and looked at there has been more consensus that's been developed over time among various agencies that are producing sampling guidance, but we found that overall the guidance still goes beyond what's been scientifically demonstrated and is in many cases based on precautions to be conservative. Most of the guidance did not address the potential pathways for PFAS to enter a sample. So materials can be prohibited in the guidance or allowed to be used only in staging areas despite the lack of a pathway. And one example of that would be prohibiting blue ice packs used that would be placed in coolers along with the samples during the shipment. In Appendix C of our guidance, we assess different pathways for sample materials to enter into the sample bottle. And for some, we concluded there's really no plausible pathway. And for others, that the resulting concentration would really be too low to make a difference or to be detected above the reporting limit. And then, since not all of this work has been published in publications, we also looked at conference proceedings and large data sets that our team had access to of equipment blanks that had been collected in large field efforts at DoD sites. And our objective here was to really go through and screen out and see if there were any positive equipment blanks that were associated with additional equipment, something that we might want to further test. And we did identify pressure transducers that had Viton components, went ahead and did a methanol soak for 24 hours and analyzed for PFAS and did not detect any in that piece of equipment. In looking at this, we had to keep in mind that a positive detection in equipment blank was not always meant to model the contribution from that equipment. So some of them were meant to test clean equipment and see if they contributed PFAS, but others were collected during this field effort really to assess the decontamination procedures and potential carryover from one location to the next that's on the surface of that equipment that's being reused. So to summarize, we came up with some recommendations for PFAS sampling and for improving guidance. We recommended focusing on avoiding fluorinated materials that were in direct contact with sample, and then using best practices to prevent cross-contamination in other instances, such as glove changes before and after sample collection. We emphasized that it would be best if guidance considers if a plausible pathway exists and to focus on those where the pathway is more likely if it's in direct contact. And then finally, emphasize the importance of decontamination from one location to the next, as that has a greater potential for impacting sample results compared to the low detections in the equipment blanks, particularly if you're working in source areas. Moving on to the topic of sample storage, our project had originally intended to evaluate sample storage and hold times, but just around the time that our project was funded, there was an article that was published that very thoroughly completed the scope of work that we had proposed to do. So I'd refer you to this publication by Woodnet and coworkers, currently SGS Access, and they assessed transformation of PFAS in samples as a function of hold time and storage temperature, and concluded that some PFAS were transformed within 14 days in refrigerated samples, and that in frozen samples of the 29 PFAS that were tested, those were stable for 180 days in the frozen samples. Compare that to a 14-day hold time that many labs are using for for modified EPA method 537. And then the draft EPA method 1633 does provide for frozen samples and an improved or a longer hold time of 28 days. And that can be really helpful when you're collecting a lot of samples in a field effort and would like to place some on hold and analyze them based on the other sample results. We moved on to looking at the topic of stratification and partitioning at the air-water interface, set up some model PVC wells in a laboratory with some sampling ports and filled them with groundwater from a PFAS impacted site and let them sit for about 3 months. And then came back and sampled and really found no significant difference in concentrations with depth or as a function of salinity that had been added to groundwater. And we concluded that there was not a need to look into this further. So keep in mind there might be stratification of PFAS in groundwater due to other reasons, but not just based on air-water partitioning, which is what this study was assessing. And then following that work and some additional work that's been published by Schwichtenberg et al. On surface water foam, we thought about air-water partitioning in surface water and surface water sampling methods. And this plot shows results from a follow-up study to assess whether PFAS enrichment in the surface microlayer could be biasing sample results. So we collected samples from the field using different methods and then compared the results. And you can see right away the highest concentration is the surface microlayer samples, or SML. And that was measured using 3 different techniques, which will be detailed in a paper that's being published by Schaefer et al. The first 2 data points on the plot show the PFAS concentrations in using a sampling method that does include the surface microlayer. So this is basically taking a scoop along the surface of the water with a sample bottle, similar to what you might do if you're working in a shallow stream and are trying not to entrain sediment into your sample. And compare that with the last 2 sampling methods that did not include the surface microlayer. And the next steps for this are basically going to repeat this at additional field sites, including some with lower PFAS concentrations, looking at different order of magnitudes, and really try to prove out this effect. The goal really is to avoid overrepresenting the surface microlayer, which might be the case if you are partially filling a bottle with surface water or maybe scooping repeatedly to get enough sample. Instead of that, we recommend in deeper water, submerging the closed sample bottle below the surface water before removing the lid, or lowering it at right angles rather than skimming across the surface. And then if you're working in shallower surface water, you could also use a peristaltic pump and HDPE tubing that would again avoid collecting the surface microlayer and overrepresenting that, and would be more representative of the bulk water. So we're recommending this as a best practice for now, and would be revisiting this once we have the additional field data. So to summarize, this project is really meant to provide a scientific basis and to provide a central resource of the scientific basis of PFAS sampling protocols. We also provided some recommendations for improving current guidance if states or other entities are planning to update their sampling guidance. For example, as I discussed, focusing on materials that are in direct contact with the samples, and then relying more on best practices where there is materials that with no real plausible pathway for affecting the sample quality. And we also reviewed the sample handling and analysis and highlighted potential for longer hold times for frozen samples, which is now being recognized under the draft EPA method 1633. And then we looked at air water partitioning and concluded this was not a significant impact for groundwater sampling, but that it could be in surface water. So we'll be taking a closer look at the sampling methods, try to avoid overrepresenting the surface microlayer. And that's all I had for today, but if you're interested in hearing more, you can visit the CERDUP ESTCP project website to download a copy, or feel free to reach out to me with any questions. Thank you.
Great, thank you, Elizabeth. While we wait to see if there are any questions, I just had a comment. It struck me as I was watching your presentation that we saw 2 presentations from 2 scientists, both working to sort of perfect the methods for sampling for these contaminants and make sure that the science is as accurate as it can be, right? You and Geosyntec with PFAS, and the Roselia project with microplastics that we heard from Rachel Miller earlier today, and I find that very impressive that that scientists are always striving to get it right and to make sure that they're collecting these samples in a rigorous, defensible method, so that the science is, can stand on its own and is defensible. And I think that's great.
Yeah, that's true. And I guess it maybe points to how far we've come as within the industry, that it's becoming more routine, and we feel that we don't necessarily need to take the same abundance of precaution that we had before, but can look more carefully at what really makes a difference. And really, can we be wearing steel-toed boots in the field while doing PFAS sampling, as long as we're changing gloves before and after samples, or do we really need to be, trying to find overboot covers and other materials? I think it also highlights just how prevalent these compounds are in the environment and all of the materials that we use on a daily basis. It maybe gets back to the previous speakers talk about, that this is really a multimedia, especially if you're looking at exposure, a multimedia exercise. So